Hello. Hello. Good evening, Sharub. How are you?
I'm fine. How are you?
Yeah, I'm good. Thanks. So, Sharub, as moderator said, like we are going to discuss complex number, the conceptual first, like 15 to 20 minutes, there will be some conceptual discussion on complex number. After that, we'll move to question paper. Okay. So let's start. Okay. So first of all, if I ask you, like how will you define any complex number? So how can it be defined, Sarup? Any idea? Yeah, Sarup, I believe like I can't hear you properly. Oh, okay. Okay, now it's fine. Now it's fine. Yes, yes, I can hear you. Yeah, how will you define complex number?
Um, Complex number.
Yeah, like you can, if you know any example, you can say, like whatever you know, you are familiar with, you can say. Do you know any complex number?
No, actually, we haven't begun learning it, so I actually have
Okay,
no clue.
no problem with that. I will tell you. First of all, if I try to find the square root of 4, so what would be your answer?
2.
2. Perfect. Now, once we are going to find the square root of negative 4, what would be your answer?
It's not possible
It's not possible. Yes. Why it is not possible?
because negative numbers cannot have a square root. I mean, negative numbers cannot be inside the square root.
Yes, perfect. So actually you can see that complex number, it's basically extension of real numbers. Okay, so it means like here in respect of complex number, what you said, it's not possible. So if I write not possible, so it means we are calculating square root of negative 4 in respect of real numbers. Okay, now the platform is real number. Now, once we move to complex number, you can see that like why the idea of complex number arises, I will tell you. So suppose this is negative 4. Now you can see that negative 4 can we write in this way?
Yeah. Yeah.
Now you can see this one can also be written as this, because square root of AB, that is this. Can we write like this?
Yes, you can.
So square root of 4, there is no problem with square root of 4. You already said the answer. It's 2. Now question is, the problem lies here. We can't find the square root of negative 1. That's the problem, right? Any negative number. So that's why, like for real number, as we define xy plane, like along the vertical axis, we define y axis, along the horizontal axis, we define x axis, and their point of intersection is called origin. So in the same way, they have defined this one, this is as real axis. The vertical one, it's called imaginary axis. Okay. Now question is, what imaginary what imaginary number is? So first of all, once you get the square root of negative 1, since you said it's not possible, they have defined it by a small I. It is basically iota. Okay. It comes from, like, it's not like normal English alphabet. It comes from actually, Greek alphabet. So iota, I. So it is square root of negative 1. So you can see that like it becomes 2i. because I is replaced by square root of negative. So this number cannot be real. So this is complex. Okay, I will discuss in respect of Argand diagram, Argand plane. This is called Argand plane, where you will find real axis and imaginary axis. I will discuss this one later, but let me ask you a few questions. Like if we try to find this one, square root of negative 9, now can you find the answer?
Yes.
Okay, let's try.
First split it into root 9 into root of negative 1.
Okay.
Then we can further write it as 3 into root of negative 1.
Yeah.
The result will be 3 iota. 3i.
Yes. Perfect. So this is the concept of this. Now question is, these are the particular example. You know that there is a general form. General form means, like if I try to define a rational number, how will you define it? Any rational number?
4.
Can you define rational number?
Rational number is a number which involves fractions and is like not recurring. It should be non-recurring.
Okay, so I will tell you, rational number, it's a number which is P over Q form. Okay, if you remember, P and Q, all these are integers with Q not equals to 0. So this is the standard form of rational number. Similarly, complex number has a standard form. It's A plus IB. Okay, A plus IB means, like, for example, 2 minus 3i, 3 plus 4i. Does it make sense? Yeah, okay. So there are two parts basically for a complex number. Suppose this is equals to z. Now question is, real part of z, that is denoted by REZ. This is equals to A. So this one, real part. Why it is called real part, you might ask me? Because this term or this expression is not associated with iota or I. This is free from I. You can see that? And so if I tell you, can you tell me what would be the imaginary part?
IB.
Yes. So actually, you know, you were almost correct, but I just want to modify your answer. Iota is not required to include in imaginary part. The coefficient of I, that would be the imaginary part. Along with the sign. Sign means this sign. Since it is plus, so it's not required to write like plus b or like this. So can you tell me imaginary part of this 2 minus 3i? Yes, negative 3. Perfect. So let's come to the next whiteboard. Here we'll discuss the diagram. So here you will find real axis. Here you will find imaginary axis. Now question is, suppose we want to plot 3 plus 4i. So it's basically an ordered pair. So you can see that along the positive real axis we have to move 3 units. Why? Because this is, if this is considered as z, so real z is equals to 3. And what about im z?
positive 4.
Okay. So you can see that along the x-axis we will move 3 units, and along the imaginary axis, how many units can you tell me?
4.
4 units. Perfect. So the point is supposed to be this. So this is the representation, and in ordered pair form we should write like this. Okay, this is called, in Argand plane, where one axis is real axis, one axis is imaginary axis. Now question is, if you try to connect this with the point of intersection, or let's say origin, let's say this point is A. So can you see that it's a line segment basically. It's called magnitude or norm of Z. Does it make sense?
Yes.
So magnitude, it is denoted by this. If Z equals to A plus IB, so it should be square root of A square plus B square. If Z1 equals to A minus IB, so modulus of Z1 would be root under A square plus minus B square. In fact, you can see that Z1, like square of negative B is equal to positive B square, right? So modulus of Z1 equals to modulus of Z. So this distance OA is nothing but magnitude or norm of Z. It's also called, there is another name, modulus. It is also mentioned as mod Z. Okay. So let me ask you one more question. Suppose Z equals to, let's say, 8 minus 6i. So can you find its modulus?
Will be 8 square plus negative 6 square, that is 100, root 100 is 10.
Yeah, you meant to say this is going to be root over 100, which is 10 units. Now question is, you are getting 10. 10 is a real number or complex number?
The complex number, I think.
10, don't you think it's a real as well? Like, isn't it an integer?
Yes, it is indeed.
Yes. So it means modulus of any complex number. You can see that whatever it is, it doesn't matter. It can be complex, it can be real, but its modulus is always real. If you see that, like, you might ask me why it happens. Answer is, this representation will help you to understand. Modulus is nothing but the distance between OA, as I said. Distance can't be, what should I say? Like, it can't be unreal or imaginary. So it has to be a real number. That's why. Does it make sense?
Yes.
And there is one more property we have to know, that is modulus of Z, that would be greater or equal to 0. Now let's come to the next question, next concept. So in the next concept we can say like if I tell you a few numbers, 3, 4, 5, -2/7, √3, -√5. So all these numbers are which type of numbers?
Rational.
Okay, you might say rational, but you can see that √3 and √5 rational number are those where we can have the exact value. So here you can see that you won't be able to find any exact value for this. So it's irrational. But all these numbers are real, right? Isn't it? All these numbers are real.
Yes.
Swarup. Okay.
Yes.
Now question is Sarup, can we say these are complex as well?
No.
Okay, first of all, if you remember, I told you for complex number the definition is this, where A and B real, isn't it?
Yes.
Now question is, if we are able to write them in that form, so it would be a complex number. Now question is, if we try to write 3, so it can be written as I times 0, √3, it can be written as this, because you know I times 0, it's always 0. -2/7, this, similarly -√5, this. Now question is, I have written only these 4 numbers. Can you compare with the standard form of complex number A plus IB?
We can.
Okay, so if we are able to compare, so can you find like this 4, like 3, √3, -2/7 and -√5, any symmetry?
No.
Don't you think all these 4 examples or in these 4 numbers, imaginary part is 0?
Yeah.
Okay, so we should remember real numbers are complex numbers let me write in the chat box so that you can take a note. Real numbers are complex number whose imaginary part is 0. Okay, once you are done, let me know. Okay, done. Now question is, if we try to plot those numbers, like let's say 3. So 3 means imaginary part is 0. So 3, 0. That would be somewhere here. So what does it mean? Like all the real numbers lies on this axis, real axis. Isn't it? So you can take a note on your copy that in Argand plane, real numbers lies on real axis.
Finished.
Okay, that's fine. So let's come to one more example, like when we write negative I or maybe I. So can you comment on this, like how can we convert it into the standard form?
By standard form, what do you mean?
Standard form means A plus IB. That is called standard form.
That's fine. From I should bring it to standard form.
Okay. So standard form means you can, don't you feel like we can't write A? So what I meant to say, standard form is this, so that we can compare with this. Okay. Does it make sense? You can see that, like, can you tell me the real part of I?
0,
Imaginary part?
1,
1. And if we try to write minus I, how are you supposed to write it in the standard form?
0, negative 1 into I.
Okay, so what would be the real part and what would be the imaginary part?
0 would be the real part and negative 1 will be the imaginary.
Perfect. So if we try to plot them, you can see that I would be here, minus I would be somewhere around here. So you can see that purely imaginary numbers lie on the imaginary axis. So you can take also a note, purely imaginary number means whose real part is 0, so lie on imaginary axis.
Finished.
Okay, that's fine. So let's come to first of all, do you have any questions? Like, we have completed basic discussions.
Now it's all clear.
Okay, that's great. So now we let me tell you a list of real numbers. Let's say 2, let's say 5 over 2, let's say 3 over 2, let's say negative 7 over 2, let's say root 2. So can we arrange them in ascending order? All these are real numbers, right?
Yeah.
Okay. So how are you supposed to arrange them?
First will be negative 7 by 2. Then
Okay.
3 by 2.
Okay.
Root 2.
Okay.
2. Then 5 by root 2.
5 by 2. Okay. So it means real number can be arranged in proper order. It means either in ascending or descending. That is, you can compare two real numbers. Now if I ask you, how will you compare complex numbers? In general, you might say all these are complex number. We can compare this. So what I'm saying, you can't say any relation between 2 plus I and 2 minus I. So no such relation. Even 3 minus I or 3 plus I. So the difference is difference between real and complex number. This is the major difference and very conceptual. Number is real number can be arranged in ordered form, while complex number can't be. Okay. So that is, if you are asked to find which complex number is greater, which complex number is smaller, so answer would be no conclusion. We can't conclude that because there is no such relation. And between any two real numbers, always know there are only three relations possible, either greater or less or equal. So like 3 and 2, so either 3 would be greater than 2, or 3 would be less than 2, or 3 would be equal to 2. So in fact you know that these three relations can't hold simultaneously. Only one of them will hold. So in fact 3 is greater than 2. This is called law of trichotomy. Law of trichotomy holds only for real numbers, not for complex number. So that's why this is the main difference. Okay, so can we move on?
Yes.
Okay. So now we have to discuss operations. Operations means, okay, before that we can discuss one more point I forgot to mention. It's argument. You know, argument, it's basically like if we try to plot, it is generally like, suppose z equals to a plus ib. So argument of z generally this. So there are two concepts like principal value and there are other values. So I'll discuss that. But what is important, like you can see, like if we try to draw any complex number, that is z equals to a plus ib. So a plus ib is somewhere around here. So if we connect with its origin, so what will happen? You can see that this angle is theta, right? Now question is, this value, it's called principal value. That is principal argument. So I'm just simply writing this one PV, principal value. So this theta, okay. And when it is like we are going to write argument for principal, that would be a would be capital, and after that a would be small. Because you might ask me like why it is so. Because if you move counterclockwise by 2 pi, so you will get another angle. Let's say this one is theta 1. So theta plus 2 pi, that will give you theta 1. Does it make sense?
Yes.
Okay. Now question is, how are we supposed to, so this is geometrical aspect, what I told you. Now question is, how are we supposed to add, like addition, like what I meant to say operation. Operation means like suppose we are going to add this two. So how are we supposed to add?
We add both the terms or e minus 4i.
Let's say this is z1, this is z2. So if we are supposed to add this two, z1 plus z2, how are we supposed to do this?
2 plus 3 while negative 4i goes with 3i.
2 plus 3i plus 3 minus negative 4i, true. Then just remember real part, like if we try to add a1 plus ib1 plus a2 plus ib2, so it would be something like this. A1, that is we have to add real parts, we have to add imaginary parts. Okay, so can you answer this now?
2 plus 3 while 3i minus 4i.
Perfect. 3 minus 4i. So what would be the final answer?
5 plus 5 negative 1i.
Yes, so we can write negative 1i means only negative I. Can you write like this?
Yeah, you can.
Okay, so what would be the answer for this? Like if we are supposed to subtract, sorry, what I meant to say, we are supposed to subtract, not add. So can you tell me?
It will be 2 minus 3
Okay,
and plus 3i plus 4i.
okay. So double negative will make it positive true. What would be the next step?
It will be negative 1 plus 7i.
Okay, perfect. So this is all about conceptual discussion. If it is required while discussing questions, we'll come back to this. So let's discuss a few questions. Nothing to worry, like it's very basic questions. So what we are supposed to do, let's start from level 1 and first questions. So here it says, which of the following? Okay, so we have to answer questions in a time bounded manner, like you have to answer the questions within 2 minutes. So which of the following is correct? So here you can see that there are 4 options, like 3 plus I greater than 2 minus I, 2 plus I greater than 1 plus I, 5 minus I greater than 4 plus I. D would be none of this. So the first one, what do you think? What would be the answer?
None of these.
None of these. Very good. How can you say that?
Well, I just applied some logic.
Okay, you applied some logic. Which logic? Like, may I know?
Like in the first A and B, both of them are obviously greater than, like 3 plus I is, if we take I as a number, we can say 3 plus I is greater than 2 minus I, while in B, 2 plus I is greater than 1 plus I. However, we don't have options for both of these, and the third one doesn't look like the answer, so I went for D.
Okay, so can you see the chat box? Like one rule, the last rule I have just written over there. Difference between real and complex number. That one. Can you check once?
Yes.
So what was that?
Real number can be arranged while complex cannot.
Yes. So arranged in ordered form. Ordered form means either ascending or descending. Like if you consider the example, like as you said, 1 would be less than 2, 2 would be less than 3. It's possible. And for complex number, as I said, it is not, there is no such relation. It cannot be greater, it cannot be less. So look at this, option A, B, C. All these are complex, right?
Yes.
So what can you say?
Cannot be arranged. So we
Yes.
cannot get to know
So
which one is greater.
yes, we can't say whether one complex number would be greater than the other or not, or less than other or not. So that's why none of this. When you see, like they are trying to find any relation between them, so always go with this option, because as I said, no conclusion can be made. Okay, is that fine?
Yes.
Let's come to the second question. So the second question says, let Z1 and Z2 be two complex numbers such that Z1 plus Z2 and Z1 Z2 are both real. Then which of these relation holds? So there are 4 options. 2 minutes for this question.
Isn't option A and option C the same thing? Same with B and
Option A. Okay. First of all, I can understand like we are not familiar with this one. Okay. Let me discuss this one. Otherwise, we won't be able to like discuss these questions. So suppose, if we consider any complex number in that way, Z1 equals to, let's say, A1 plus IB1. Okay. So Z1 bar. So there is a special notation. It's bar. This is not equals to Z1 in general. So how will you define this one? Just you have to, what we are supposed to do? Just we have to change the sign before I in that way. Okay. It's as if like this is called conjugate. Like all of you like familiar with this. Like when we used to have this surge in the denominator, we used to rationalize it, if you remember. So it's basically the same. So it's not like, you can see that option A and option C, there is a difference. Z2, negative Z2 in option A, in option C, negative Z2 bar. Does it make sense?
Yes, there's a bar.
Okay, and I will come to this question and let me tell you one more thing here. Suppose Z1 equals to A1 plus IB1 and Z2 equals to A2 plus IB2. Now question is, when this complex number are equal? So these are equal only when real parts are equal as well as imaginary parts are equal. Only then, vice versa. It means if you get this, if you are able to show real parts and imaginary parts are equal, so it means this complex number are also equal. Does it make sense?
Yes.
Okay. So now we can try this one. Let's try question number 2.
Option D.
Okay, how can you say that?
Well, the first three options don't seem to be the answer, and the fourth one can only happen when both real and imaginary numbers are equal, but doesn't seem like that.
First, you can see that, like, if we consider, let's consider this one in a, here we have enough space. Like, if we try to consider Z1 equals to, let's say, A1 plus IB1 and Z2 equals to A2 plus IB2. Okay. So they are saying Z1 plus Z2. It's real. So it means this. Like if we add, won't we get this? Now question is, if Z1 plus Z2 is real, so what does it mean?
The end answer should be real.
I'm not getting you. Like, it means imaginary part is, this part is 0, right? Only then it's possible. So B1 plus B2 is 0. So what would be the relation between B1 and B2?
Both are imaginary.
B1 plus B2 is 0. So if can we transpose B2 to this side?
Negative B2.
Perfect. You got B1 equals to negative B2. Okay. Now question is, if you see that the question says Z1 times Z2 are also real. So first we have to multiply. So if we are, sorry for this, we are doing where? So Z1 times Z2. So if we are going to multiply these two, so what will you get?
A1, A2,
Okay.
A2
Yes.
plus 1 IB2,
Plus.
A1 IB2.
Okay. So we are writing here A1 like I A1 B2. After that
IB1, A2,
okay,
I-A2,
B1 A2. So we have factored out I. So in that way, what would be the other part? Like what would be another?
IB1 into IB2.
Okay. So we basically will get I square B1 B2, right? So can you tell me the value of I square? What was, can you tell me the value of I?
Value of I.
Yes. Isn't it square root of -1?
Yes.
So what would be the value of I square?
-1.
Perfect. So what would be the value of I square B1 B2?
Negative B1 B2.
Okay. So we got this. It's saying it's a real number, I believe, like both real. So don't you feel like this part will also be 0?
Yes.
So from that, this is going to be this. Can you write like this?
Yes, we can.
Now you can see that what would be the relation between B1 B2? B1 is negative B2. B1 is negative B2.
B2.
Now in place of in place of B1, can we write negative B2?
Yes.
So what will you get? A1 B2, A2 B2. So B2 can be cancelled out. You will get A1 equals to A2, right?
Yeah.
So Z1 you got A1 plus IB1, and Z2 you got A2 plus IB2. Now we are trying to substitute the value of Z2 here, like it is going to be A2 is equals to A1 and B2 is equals to negative B1. So don't you think Z2 is equals to Z1 bar?
Yes, it is equal to 7 bar.
Or Z1 equals to Z2 bar? That can also be said. Okay, can we say that?
Yes, we can.
So which option for question number 2?
B.
Yes, it would be B. This one. What about question number 3? Question number 3 says, let Z be any non-zero complex number, then arc Z plus arc Z bar equals to what? Yes. What would be the answer? Okay, I will just tell you one more thing. Like Z1 equals to, if you feel like if we consider A plus A1 plus IB1, right? So arc Z1, it's basically tan inverse B1 over A1. So now can you try?
Then 0.
Is it 0? How can you say that?
No.
If it is 0, how can you say 0?
It's not 0. It's not. I think the answer is pi.
Okay, you got pi. How did you get this?
Because arc z will have a value while arc z bar will have its inverse value.
Okay.
So when you add, make the denominator same and cancel, you will get pi.
No, first what we can discuss, like suppose if we take one particular example, here we can see, so that it would be a lot more easier to discuss this. Suppose if we consider this one as 1 plus I, so what would be the value of arc Z1? So wouldn't it be tan inverse 1 over 1, right?
Yeah.
So don't you think this is going to be pi over 4? Now question is, if we are supposed to find this one, can you tell me what would be the answer for Z1 bar? Like if you remember the concept of conjugate,
1 minus
1 minus I, true. So if it is so, what would be the value of this? Now always remember, if theta is the argument, so there is a restriction on this. Restriction means theta must lie on this. Like negative, what I meant to say, negative pi to pi. So this would be the range for theta. Okay, so if we try to use any diagram, so it means if you try to move theta here, so it can be from this, and you can see that here it could be like this. Does it make sense? Now question is, here you can see that, can you calculate arc Z1 bar?
can you move this?
Yeah, what would be the answer for arc Z1?
I can't see the question. Can you move the screen a bit?
Yeah, okay, you can't see. Now what about now? Can you see that?
Yes.
This one.
To be tan inverse 1 by 1.
You got tan inverse 1 by 1.
Negative 1 by 1.
Okay, so tan inverse negative 1 by 1 equals to what?
Negative pi by 4.
Okay, now question is whether negative pi by, if you try to write negative pi by 4, will it lie on the, the proper range?
Yes.
Okay, because we have to ensure that, like you can see that, like it should lie Just we have to mention this. Otherwise it is not possible. So here it lies in this. So what does it mean? Like if we try to add, what will you get? Pi over 4 plus of negative pi over 4. What would be your answer?
0.
Yes. So does it make sense? How are you supposed to do this question?
Yes.
Let's come to question number 4. It says argument of 1 minus I root 3 over 1 plus I root 3. Okay, as you can see that moderator sent you a message. All details for 2-year JEE and SAT1 coaching program has been sent, and you will get a call, like our team will call your father tomorrow after sending feedback. Okay, and you know, we are last 5 minutes of the session, so I believe we can discuss this question as well. So what would be the argument of 1 minus I root 3 over 1 plus I root 3? How are we supposed to do this?
You can
Swaram?
solve it using conjugate.
Okay, but do you think it is in A plus IB form?
Yes, it is. It is right.
Is it? How can you say what would be the value of A?
A will be 1 while IB is 1 by root 3. I mean 1 root 3. I root 3. Sorry.
First of all, Swarup, you can see that it's a fraction. It's a complex fraction, in fact. So, whenever you get complex fraction, it is always better to express in the standard form like A plus IB. Okay. So, by multiplying, it's basically the same concept of rationalizing. So, let me show you. Like it is going to be 1 minus I root 3 over 1 plus I root 3. Now question is, how are we supposed to write in this form? A plus IB form. You can see there is a multiplier. It's in the denominator. It will give you idea about the multiplier. For rationalizing, how are we supposed to rationalize this one? Swarup?
1 by 2 minus root 2 into 2 plus root 2 by 2 plus root 2.
Perfect. So can we do the same here?
Yes.
Okay, so what would be the multiplier?
Into 1 minus I root 3 by 1 minus I root 3.
Okay, that's great. So if we do this, what would be the denominator?
It will be 1 square plus I root 3 square.
Yes.
It will be 3I square 3.
Yes. So what about the numerator?
Numerator will be in A minus B whole square form. So 1 square minus 2 into 1 into I root 3
Okay.
plus root 3 square. That is 3.
I root 3 whole square.
Yes.
Yes. So what would be the value of I square?
I square value is negative 1.
Okay. So if we substitute there, so it is going to be 1 minus, you can see that I square is negative 1. 1 minus 3. And this one, here you can see that it's 3 because root 3 square is 3 and I square is minus 1. So you can see the numerator becomes this and the denominator is this. So minus 2 over 4 minus 2 over 4 root 3I. So this is going to be negative half This is going to be root 3 over 2i. So this is now in a plus ib form, where the value of a is negative half, the value of b is negative root 3 over 2. So can we have the argument now? Okay. So can you find it out?
For this question or worksheet?
Yeah, for this question we are discussing the same questions of question number 4. So what would be the argument?
Oh, okay. By argument, what do you mean?
Argument means, like, suppose if you consider this one ARG, like this one is Z. So what would be ARG of Z? Don't you think it is tan inverse B over A?
Oh, like that argument. I thought the
Yeah.
other argument.
Okay, no problem. So can you find it out?
Yes, so it will be negative root 3 by 2 by 1 by 2. So that will be negative root 3 by 2 into negative 2.
Okay. So you meant to say it is going to be negative root 3 by 2 over negative. So it is going to be tan inverse root 3. Right?
Yeah.
So what would be its value?
1.74.
No, you can remember, like, if we try to write over here tan 60, that is tan pi over 3, this is root 3. So its principal value, it's pi over 3, right? Now question is, you can see that the problem here, both A and B is negative. So in which quadrant it must lie?
Third quadrant?
Yes, third quadrant, true. So how are we supposed to find it in the third quadrant? So don't you think we have to add with pi? So it is going to be 4 pi over 3. Now question is, you might ask me, it's greater than pi. How can it be possible then? If you remember, I told you the range of argument lies in that way. So 4 pi over 3 somewhere around here. So if you follow this one, so it will definitely get covered by this negative pi. Does it make sense?
Yes, sir.
So that would be option D. Okay, first check the first 4 questions and let me know if there is any doubt. First 4 questions we have discussed.
In Z1 and Z1 bar, is Z1 bar is supposed to be the conjugate of Z1, right?
Yes, true.
Okay, then there's no doubt.
Okay, so that's fine then, Swarup. That's it for today. Hope you enjoyed the session. Thanks a lot.
Yes, sir.
Bye. Good night.